Good evening, sir.
Yeah, good evening. Good evening, everyone.
Good evening, sir.
Good evening.
Good evening, sir.
Yeah, good evening. Good evening, everyone. Just in 1 minute, we are starting.
Yes, sir. Sir, last week, the two physics classes, I was not there, sir. Like, I missed last week classes, sir. From
So
from Tuesday to
class recording is available. You can access that.
yes,
Okay.
sir. Yes, sir.
And
From Tuesday to Friday, I was in there.
okay,
I informed the ma'am also.
just 1 minute. Okay. So in the last class, we had done about forces. We had extended the chapter of force and pressure. Right? We had done something extra with that chapter. Today, okay, just check out what all are the chapters from. What all are the chapters other than this? What we have done in physics and chemistry?
Sir, may I? Sir, may I, sir?
Sir,
Yes.
sound.
Sir,
Sound.
coal and petroleum.
Okay, which we have already done.
Sir,
Uh,
sound.
Sound. Okay.
Yeah, we did not do sound.
No, sound will not be doing right now as sound chapter. I don't think that you will be getting in your such exams. Sound chapter most probably.
We actually have sound in our half yearly, sir.
Yeah, so that's why we are light also I think will be around half yearly or after the half yearly.
Sir,
Okay.
friction.
sir, my half yearly portion is done in the science, sir.
Okay, okay. So I
Biology is
think
done. Only two
okay,
lines.
I think today we shall start with friction. Again, give a quick revision of friction. Okay.
Sir, in my school, they started friction.
Yes. So this will give you a better idea about friction, and most of you have done. So let's do friction, right?
Yes, sir.
Okay.
Did you pay this?
So what is friction? How do we define friction?
Friction is a contact force,
Hmm. It
and
is a contact force. Very good.
and
Sir,
it stops.
Friction opposes motion, sir.
Yeah, friction always opposes motion. Friction is a
Same
type of
same
force.
point, sir.
Yeah, friction is a type of force which always opposes motion.
Sir,
So,
one more point, sir.
yes.
Contact force.
Friction is caused by the uneven surface, sir.
Okay, so that are the causes of friction.
Sorry,
First is
sir.
okay.
Friction
So
is a contact
at
force.
particular surfaces of contact when one body slides or rolls or tends to do so on the surface body of another body, sir. Friction.
see, friction will be there when there is a relative motion between two bodies. Okay, so whenever there is a relative motion between the two bodies which are in contact with each other, so then there will be friction. So friction is a type of contact force. It always acts in a direction opposite to the direction of motion. Okay, can friction cause motion?
Uh, yes.
Yes. or no?
No, sir.
First of all, friction, it is a force. It is a type of force that act in a direction opposite to the direction of motion. That act in a direction opposite to the direction of motion. Okay. So friction always act in a direction opposite to the direction of motion, or you can say friction is a force that opposes motion. So the direction in which there is a motion, or it is a contact force. Friction is a contact force. Also, it acts between two bodies when the two bodies, or when there is a relative motion between the two bodies. When there is a relative motion between the two bodies. Or you can say, even if there is no motion, if one of the bodies tries to move over another body, so then there will be a force of friction. Okay. So force of friction can be studied by different ways. There are different methods for studying the force of friction. So first we study what is the cause of friction, and then we decide what are the factors on which friction depends. We will see cause of friction. Okay, so what is the cause of friction?
Sir, irregularities on the surfaces.
Okay. So friction is mainly caused due to
Sir, doubt, sir. What is the last word, sir? It acts between the two.
bodies when there is a relative motion between the two bodies. Sorry for the spelling over there.
Yeah, sir. I did not understand. Sorry, I thought it was some terminological word.
Okay. So
Sir,
yes.
sir, it depends on the surface, sir.
Yeah, it depends on the okay. Cause is irregularities present on the surface. Okay, so see how it looks. I will show you something. Okay, so as we know that a blade a blade is very sharp and smooth, right?
Yes, sir. It's streamlined, sir.
Okay. So today I'll show you. Let us try to find out a picture of blade, or we will see a microscopic view of the picture of a blade. We'll try to see microscopic view of different surfaces, and we'll see that almost all the surfaces are irregular. Okay. So microscopic view of blade. So let's see. As you know that blade is very smooth. So see how does a microscopic view of a blade look like. See, even the blade which is very smooth, you see how rough it appears under a microscope. Even that blade also appears to be irregular. See, there are irregularities present even on the surface of the blade. You can see here. Okay. Even if we observe different others, let's say observe irregular microscopic view of some other material. Let's say we obtain marble. So as you know that marble is also very smooth. So see, again if you see of even if I take a smooth marble. Okay, see. Even if I take a smooth marble, so it also has irregularities present on the surface. You can see even it has irregular surfaces. Okay. We will also observe different other surfaces where there will be presence of the irregularities. Yes, I think Saiti, are you trying to speak something?
No, sir.
Sir,
Okay. Yes.
what if we take hair, sir? Hair is very soft. No.
Okay, so hair is also very soft. So let's see here. We want to see that all the surfaces they are very which appear smooth to us. So at the microscopic level, they are also not smooth. They are rough. See this one. Does it rough? Is it rough?
Yes, sir. Yes, sir.
Yes. So see all the surfaces which we see to be smooth or may appear to us as smooth, they are actually rough. Okay, at the microscopic view, we observe them that they are rough. Let's try to observe here ice. As ice is very smooth, even I haven't seen a microscopic view of ice. So see, are there irregularities present on the surface? Or let's say something like this, maybe you will be getting,
Yes, sir.
see, even a surface of ice which appears very smooth, it also has at the microscopic level, it has irregularities. Uh, let's say I want to see a clear picture so that it will be clear to you. Okay. So see this picture. It shows some irregularities present on the surface of ice. Okay, so whatever surfaces, if you observe them under a microscope, you will observe that those surfaces which may appear smoother to us, they are actually irregular in their shape. Got it? Yes. Any
Yes,
other?
sir.
So see, all the surfaces they are which appear to be smooth, they are actually rough. At the microscopic level, they are rough. So like this one, different views are there. So irregularities present on a surface, they make the surface rough. Okay. So whatever surface we take, those two surfaces they are always rough, and hence they can cause friction. Okay. So they will be causing friction. So something like this happens. If you have a surface to be irregular like this, here we take another surface being irregular. So the two surfaces they get entangled with each other. Okay, and hence one
Sir,
of the
like
surface.
they stuck to each other. They stick. Like
Yeah, they stick. They are getting entangled. Okay, so when they are getting entangled with each other, so one of the surface it prevents the movement of the other surface. Nowadays, a microscopic view or a high idea is also prevented. That is, nature of the surface is a region, but there is still another region for the friction. Okay, and that is the atomic attraction, electromagnetic or electrostatic forces of attraction between the atoms is still another idea for the cause of friction. Okay, so another idea or another reason behind friction is that here we can include the second point to be electrostatic forces of attraction between molecules. So due to the electrostatic forces of attraction between the molecules, okay, so that also causes friction. So these are the two causes of friction. Either, so this the second point which I have written, this is the modern view of friction. This we call as the modern view. And this is the traditional view or the older view that the irregularities present on a surface, they are the cause of friction. Got it? Yes? Anything else?
No, sir.
No. Okay. Okay. So these are the causes of friction. Then now we move on to what are the factors on which the friction depends. Okay. So factors
Mass of
on which
the
friction depends, the different factors which affect friction. Okay. They
mass of
are
the
the,
object.
yes,
Mass of the object.
okay, not the mass, the weight of the object. Factors on which the friction depend, we call it as the weight of a body.
Sir, mass and weight are different, sir.
Yeah, they are different.
Okay.
Mass and weight, they are different. So weight is just a type of force, whereas mass is the property of the matter. So these two things, they are two different things. So yes, factors on which friction depends. It depends on weight of the body. Then it depends on nature of surface. Okay, is there any other thing on which the force of friction depends?
Shape of the object.
No, not the shape of the object.
Movement. The force. Movement of the object.
No,
Force. The force of the object coming and the force that the friction is keeping.
okay. See, these are the two factors on which the force of friction depends. It depends on the weight of the body and it depends on the nature of the surface in between. Okay, nature of the surface in between them. So let us see what were the activities which we listed out here that could be done for understanding the friction. Okay. Let's now try to see it with the help of your NCRT. You see the activities which we had discussed here. For example, here the boy slipped off. So why did the boy slip off?
Because he was running so fast and the friction got stopped him because of the banana peel he stepped on.
Yeah, there was a very less friction between the banana peel and the road, and hence it slipped off. So it also the picture also shows that friction is necessary for walking. If you are walking, so friction is necessary for walking. If you don't have friction, so you won't be able to walk.
Walk.
Now in the second picture, you observe here two scenes are shown here. In the first one, the book is being pushed towards the right. Okay, you can see there is our original position here. So this one is the original position of the book, and here it has been pushed towards the right. So the book is pushed towards the right like this. Okay. So when the book is pushed towards the right, now the force of friction, it is acting in the opposite direction. when the book is moving towards the right, then force of friction is acting towards the left. So why did the book stop here? When I pushed the book in the right direction, why did the book stop? Yeah, why did the book stop? Suppose I pushed this book in this direction towards the right. So why did it stop, Sreshta?
So due to friction.
Yeah, due to friction. It was due to friction that the book stopped. Okay.
Sir,
Then
can you repeat the question? Your voice is
Sir, may I?
breaking.
yes,
Sir, may I? Sir, I got a question.
okay, ask it.
Sir, because the friction is like the
The friction is
so the friction is only active for some time and it is stopping the object as they applied a certain force and so that it is stopping at a point.
okay. So see, what we want to understand here, that friction always act in a direction opposite to the direction of motion. Okay. Here we were trying to move the book towards the right and it is being opposed towards the left. So there is some force which is not allowing it to move, and that force which doesn't allow it to move, it is acting towards the left. So here in the first picture, the force of friction, here the force of friction is acting towards the left. In the second case, this is the original position of the book, and from here the book is being pushed towards this direction. Okay, the book is pushed towards the right. Okay, so when the book is pushed towards the left, it starts moving towards the left, and after covering a certain displacement, it stops. So why the book stops here? Yes, why the book stops here?
Because the friction is applying force on the book to stop.
Because the friction is applied, and in which direction the friction is
The
applied?
friction is
Right
opposing
side.
the force, sir.
That's left side.
Towards the left side.
So the second picture is towards the left side and
Okay.
the first one is right.
In the second picture, the force of friction is acting towards the right direction. The book is moving towards the left direction.
Yes, sir.
Okay. And in the first picture, the book is moving towards the right, but the friction is towards the left.
Sir, like in any situation, sir, friction is opposing it in an opposite direction, no, sir.
Yeah, it is in any case, the friction is always acting in a direction opposite to the direction of motion. Okay, so let's say I will show you one more thing, and you have to tell in which direction will the force of friction act. So suppose I have an inclined plane. I hope everyone understands what is an inclined plane.
Yes, sir.
Okay, a steep like this. An inclined plane, which can be assumed to be your that's
Slide.
float,
A ramp,
slide,
sir.
yeah, a
A
slide
ramp.
or a ramp. So if suppose I roll a ball from here, the ball continues to move in the downward direction. Okay. So the ball is moving towards the downward direction or in this direction. So in which direction should the force of friction act?
To the right side.
To the left side.
Okay,
Left
no,
side,
okay.
sir.
In the upward direction or in the downward direction?
Upward
The
direction.
downward.
Upward
See,
direction.
this is the direction of motion. Okay, this is the direction of motion in which the ball is moving. So in which direction is the force of friction?
Upward direction.
Upward, sir.
Upward
Upward
direction.
direction. Okay, so force of friction will be there, which will always act in a direction opposite to the direction of motion. So why the ball doesn't stop? Why it continues to move?
The friction is weak. Like
Sir,
the
due to
friction is
gravity.
applying low force
right, sir?
The friction is,
in the incline on the inclined plane.
yeah, it is on the inclined plane. So there is gravity which is pulling this downward. and of course the gravity is greater than friction. That's why it starts moving. Okay. Now let us try to do this activity with some other thing. Let us take a block and then try to do this activity. But suppose
So
our
then also
yeah.
Sir, then also it won't stop, sir. The block
Yeah,
slides.
yeah. But here we are going to do something else. Okay. So here I have an incline, but now my slope can be changed. Okay. So I can keep the slope something like this. Then I can increase the slope. I can increase the slope, increase the slope, so on. I can increase the slope like this. Okay. So do you think that at it is possible for the block to slide at every angle?
No, sir.
No, sir.
At some
So
of the place, it stops the sliding.
yeah, so let's say I have one of this angle and here I make another one. So in which of the two cases is the block likely to slide?
Second one.
Second one, sir.
B.
Second one.
Second one.
In the
Second one.
second one, why?
Sir, as
Because
it's
it is
more
more,
Inclined.
it
It
is
is
more
more
parallel.
inclined.
Yeah. So can I say here that the force of friction is opposing its motion?
Yes, sir.
Yes. So in the first one, can I say that uh, friction is equal to the gravitational force? That's why it's not moving.
Yes, sir.
Yes, sir.
Okay.
Yes,
In the
sir.
second one, which force is greater, gravitational force or the
Gravitational force.
frictional force? Which one is greater?
Gravitational force. Gravitational force.
gravitational force.
Yeah, in the second one, when it's moving, so here we have gravitational force being greater than the frictional force. When gravitational force is greater than frictional force. Got it? Okay. Now another concept here. The frictional force is a self-adjusting force. You see? So what do I mean by this? That the frictional force is a self-adjusting force. Okay. So see, the value of the frictional force, it changes. It's not always constant. For example, बनवा लिया जल्दी बनवा लिया से ठीक है ठीक है अच्छा so see here I'm taking here three cases and you will explain me what is the force of friction in each of the case. It's the same block. I'm trying to pull it with the help of a spring balance. I'm pulling the three blocks. So here in the first one, I have attached this with the help of a spring balance. So here spring balance reads a force of, suppose it reads a force F equals to 5 Newton. For the second one, it reads a force of, let's say, it reads a force of 7 Newton. And for the third one, it reads a force of, here it reads a force of, let's say, 10 Newton. Okay. So for this one, for the first one, when I applied a force, of 5 Newton, the block does not move. it doesn't move. Okay. When I apply again here 7 Newton, the block doesn't move. And when I apply the force of 10 Newton, the block starts moving. So in the first one, what was the value of the force of friction for the first one? What was the force of friction for the first one?
5 newtons.
How much?
So the
5
force
newtons.
of each one is like the first one has low force, the low friction, and the second one has like 7 Newton force, that is minute percent, and 10 Newton is much in the force of.
Okay. Oh, no, I want the amount of friction. What is the value of the force of friction in the first one?
So 5 newtons.
5 newtons, exactly. Since the block is not moving. Okay. So whatever force we are applying, the same force is being applied by the friction. So the friction is also pulling it back with the same amount of force. And that is why it doesn't move. So here the force of friction is also 5 newtons. See, the block is the same, the surface is the same. For the second one, again I pull it with a force of 7 Newton. So force of friction is 7 Newton. Because the block still doesn't move. Now what is the force of friction for the third one?
11 newtons.
11 Newton or 10 Newton?
So, but if it has the same amount of newtons,
It
it will
doesn't
not
move,
move.
sir.
Sir, it doesn't move now, sir.
Yes.
Sir,
So, yes,
I
so
think
what?
It should be 10
sir,
more.
sir, I think the friction should be less than 10 newtons.
Yes, so for this one, your force of friction is less than 10 Newton. It's less than 10 Newton. Anything less than 10 Newton. Okay. Understood this? So can I say that force of friction is adjusting itself?
Yes, sir.
Sir.
Yes. It adjusts itself. In the first case, the force of friction was only 5 Newton. In the second case, the force of friction was 7 Newton. In the third case, the force of friction was 10 Newton. So we observe that force of friction, it grows, it increases as we increase the force applied. Okay, and a certain stage comes when the force of friction becomes maximum and it cannot increase beyond that. So when the force
Sir,
of friction, yes,
but if the force of friction is also more, it is friction is just like a change of direction, right? But it also makes the object move.
repeat again.
So friction also makes the object move as the motion.
Friction also makes the object move, yes.
So if the in the third block, if it needs to start moving, it can, the force of friction can be less than 10 newtons or more than 10 newtons also, right, sir?
Force of friction can be, again repeat, sorry, I didn't pay attention. I was somewhere.
To make it start moving, the force of friction can be less than 10 newton and more than 10 newton also, sir, right, sir?
No, not more than. It has to be less than 10 Newton. Okay. If the force
So
of friction
friction
is, yeah,
it also makes it move only, right, sir?
no, friction is not making it move. Okay. Friction is not making it move.
Sir,
Friction is just, yes.
that a situation will come where friction cannot exceed beyond that limit, no, sir.
Yeah, friction cannot increase beyond a limit.
Like in which situation, sir?
In the last one, see, we observed the friction can't increase more than 10 Newton.
Sir.
Okay, sir.
Okay. Okay. So bye everyone. We'll see again in next class. We'll continue with friction a little more. See, now getting into the chapter deeper and deeper. Okay. It's the chapter is same, but still we are going deeper into the chapter. Okay. Okay. Bye all of you. See you again.
Next, which chapter we are going to start?
Thank you, sir.
Yeah. What happened?
Sir, next, which chapter we are going to start?
The same chapter. We'll continue with friction.
Thank you, sir.